Hello students, in this video we are going to continue with our lessons on ordinary level organic chemistry, chapter 3, titled the IUPAC nomenclature for aliphatic compounds. But wait a minute, what did you learn in chapter 2 entitled terms used in organic chemistry? We learned about the electronic configuration of carbon, in which case we define the electronic configuration as the arrangement of electrons in the different shells of an atom. The electronic configuration of carbon being element number 6 with 6 electrons is 2, 4. Carbon therefore is capable of using its 4 valence electrons to form either single covalent bonds, double covalent bonds, or triple covalent bonds. We find single covalent bonds in alkanes. Alkanes have a tetrahedral shape with a bond angle of 109 degrees. Alkynes have double bonds with a planar shape with a bond angle of 120 degrees, and alkynes have a linear shape with a bond angle of 180 degrees. I want you to remember that every shape has a specific bond angle. Every shape has a specific bond angle. Once you think of linear shape, the bond angle is 180 degrees. Once you think of planar or trigonal planar specifically, the bond angle is 120 degrees. And once you think of tetrahedral, the bond angle is 109 degrees. So shape and angle are compatible. Other terms that we got ourselves familiar with in chapter 2, used in organic chemistry, were saturated and unsaturated compounds, organic compounds specifically. We equally talked about homologous series. We talked about alkyl groups. We talked about functional groups. We talk about empirical and molecular formula in that very chapter. Now, among these terms, what is the relationship between the chapter that we are presently going to study, that is to say, the IUPAC nomenclature for aliphatic compound, and the previous chapter, terms used in organic chemistry? For you to name a compound, there are a number of things that are very important. For example, the functional group. In our last class, we actually talked about the functional group as one of the terms used in organic chemistry. And we defined the functional group as an atom, group of atoms, or a bond that determine the main chemical properties of a homologous series. And today, we are going to learn about the IUPAC nomenclature for aliphatic compounds. So functional groups are going to play a great role here. Whether alkyl groups or functional groups in general, they are going to play a great role in the nomenclature of aliphatic compounds. So you listen attentively as I discuss on the IUPAC nomenclature for aliphatic compounds, so that naming of organic compounds will be done with maximum ease. The abbreviation IUPAC means International Union of Pure and Applied Chemistry. In the IUPAC nomenclature, every name generally consists of a prefix or prefixes, a root or parent, and a suffix. Now, all names must have a root and a suffix. Now, let's talk about the root. The root is generally an aliphatic hydrocarbon. The term aliphatic means belonging to any organic compound of hydrogen and carbon, characterized by a straight chain of the carbon atoms. Three subgroups of such compounds are alkanes, alkenes, and alkynes. The systematic name of a compound is formed from the root hydrocarbon by adding a suffix and prefix or prefixes to denote the substitution of the hydrogen atoms. Remember that the aliphatic compounds are derived from the root hydrocarbons either by the replacement of hydrogen atoms by alkyl or functional groups, or by the introduction of multiple bonds, that is, double or triple bonds. The following table represents the parent or the root hydrocarbon according to the number of carbon atoms. There are remarks that you're supposed to make from the table. One of such remarks is that when you have one carbon atom in the root or parent hydrocarbon, we call it meth. When you have two carbons, we call it eth. When we have three carbons, we call it prop. When we have four, we call it but. 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. Now let's talk about two suffixes or suffix. A suffix is added to the root to indicate the presence of the principal substituent, which is also usually the principal functional group in the molecule. All members of the same homologous series, that is to say homologs, carry the same functional group, hence the same suffix. Remember that the functional group in any homologous series is in charge of determining the main chemical properties of the series. Now let's look at 3, prefix or prefixes. Now prefixes are used to indicate the presence of substituted alkyl or functional groups other than the principal functional group. The position of substituents in the carbon chain or skeleton are also indicated by prefixes. The prefix cyclo, for example, is added to the name of corresponding cyclic aliphatic compound, e.g. cyclobutane. That's butane in a cycle. Now, when we have more than one of the same substituent group, we use multiplying prefixes such as di, tri, tetra, and so on. And these prefixes, we don't use them in alphabetizing. There is a big question that we have to answer before we proceed with nomenclature of some aliphatic compounds. The question is, how do we number the carbon atoms during nomenclature of aliphatic compounds? How do we number the carbon atoms during nomenclature of aliphatic compounds? So you listen attentively. The rules that are involved in numbering the carbon atoms in aliphatic compounds. Now, numbering is done in the longest continuous carbon chain so as to give the lowest possible number to the group cited as suffix. And also numbering is done in the longest continuous carbon chain so as to give the lowest possible numbers to the groups cited as prefixes. Now, before we proceed nomenclature, let's answer this last question. What are the basic rules to name organic compounds? What are the basic rules to name organic compounds? Now, the first one is we take the longest continuous carbon chain to be the root hydrocarbon and name it according to the number of carbon atoms it contains, adding the appropriate suffix to indicate the principal substituent group. And the second rule is that we number the carbon atoms in the root hydrocarbon from the N, which will give the lowest number to the suffix, and then the prefix or prefixes. Thirdly, indicate the other substituents by prefixes preceded by numbers to show their positions on the carbon chain skeleton. And the fourth rule is that numbers are separated from names by hyphens, that is a dash, and numbers are separated from numbers by commas. This rule in particular has an exception in the nomenclature of esters, as you see soon. The fifth rule is that if two or more different substituents are present, we have to cite them in alphabetical order. And lastly, if two or more identical substituents are present, we have to use the prefix or prefixes di, tri, tetra, and so on. But these prefixes are not used for alphabetizing. These prefixes, di, tri, tetra, and so on, are not used for alphabetizing. It's very important to note this. These are some 6 basic rules, but I will not tell you that this is the end of the world as far as these rules are concerned. The more you name compound, the more you develop self-rules, your own rules to name them. And when you find out from compounds in different textbooks and scientific literature, you find them just okay. So you have to develop your own self-techniques on how to name organic compounds whenever you come across them. So these are the basic rules to name organic compounds. Basic rules to name basic organic compounds. for the table involving the homologous series, the functional group, the name of the functional group as suffix, the name of the functional group as prefix, and examples, see my Facebook page, OBI.S.N, all in capital letters. I'm going to end the class of today at this level. In our next class, I will not go directly to chapter 4. I will rather solve some examples. I will take some examples of organic compounds and explain how the nomenclature is done in a very simple way, in order not to miss this important part of organic chemistry, namely nomenclature. Just like this video, subscribe to my channel, and hit the notification button so as to receive notification, especially in that class having to do with nomenclature of some aliphatic compounds. Thanks for your keen attention. Thanks for watching. See you in my next video. Bye bye.